Python that they talk about. And I did create a notebook, which we can pop into as well to just see that it actually works as it describes on the web. So let me share the document page here for a minute. So share, and we're going to share that. So that should be my web browser. Hopefully you're seeing that. Okay.
That's good.
Yep. So this is something I found. I've been tasked with working on some visualizations for our raster data. So raster data, our views of the landscape and the data that lays upon it. So as you sort of this very high level introduction level in this document, just as basically a raster. Think of it as just a two-dimensional array laid out in X and Y, or longitude and latitude, and each cell has a value in that array, and that value could be the elevation map, it could be a land use type, it could be a temperature, it could be whatever that piece of data might be, and we often deal with many of those at the same time. So the question of how do you bring in this data, slice it into the pieces you want, and combine them from different sources, because there is a inherent projection with raster data, which is how it is aligned with the land surface upon which it was applied. And you'll find that oftentimes, if you have two different sources of raster data, they won't have the same projection. So you need to move between them. And how do you align them and line them, put them up to have sort of a composite image? And this discussion today is just one library that helps us do that. So what kind of things can, there's another quick example just to wrap your head around. For instance, if you wanted to do some arithmetic, some work between different rasters. This example here showing that you could get a digital service model, which shows you the elevations of all the things that were seen either from a drone or from satellite or from a LiDAR. And you could get a digital terrain map, which says, well, this is the ground, and we've, basically ignores all of the canopy and all of the things growing on the ground. If you subtract the two, you end up with a canopy height, which basically levelizes the ground and just says this is how high the canopy is above the base of those trees, those bushes, those whatever. So by bringing in different sources from different rasters and doing differences between the values you might find in them, you can extract useful information like how high the canopy is above the surface of the landscape. So what do we use? In this case, we're going to talk about an extension to the rxarray library, which is sort of a combination of raster.io, which is a different library. So they took pieces of raster.io and layered it on top of the rxarray library. And now there is a library out there called rioxarray. So raster.io xarray. And we're going to pull, this article uses that to go ahead and pull stuff in. So it's as easy as importing the typical players and GeoPandas. I think we talked about GeoPandas last week a little bit. GeoPandas and xarray are rioxarray are the two that we're going to tinker with today. Opening up the basically, find your data, and opening your data is as easy as that. Just open the data set. And NetCDFs is a pretty popular way, but there's all sorts of things that you can read to get data. You can get GeoTIFFs, you can get GeoJSONs, text rasters, NetCDFs. Most of these data types can get pulled in. What else is going on here? So they just tell you basically what you found out, that we've got x, y coordinates lurking in there. And this, what you may notice when you load your raster data is that if you do a quick plot of it, you'll find that you don't see useful things. So if you're looking for elevations and you're seeing a whole bunch of negative values, it's maybe not what you would expect. And what that is often indicative of is that there is there is this default value assigned to a raster typically for what is non-data or garbage data. So it's if you have a raster defined, but there's only a section within that raster which has your valid data, there'll be a boundary of no data around it. And that no data can have a default value. And in this case, the default value is a negative value, just to indicate that it isn't of interest. And you see that there was a whole bunch of stuff that's negative. So what's recommended or common practice is to basically find your min-max values. You can find, where is it dumping out here? It's saying you can ask for what is the no name value, the no data value. You can see here the minimum value that it has is this, extremely large negative value. And there is a query which is lurking here. Missed it.
Scott, it's up above when you print the data set out. It has a value called fill value.
Yes, there it is. So there's a value, and you can query the value and report it out, and know that that's the value that we want to get rid of. We want to not include that in any of our data analysis. So what can be done here after we've determined that we don't like the fact that we have this garbage data in there is this squeeze. Yeah, here it is. Basically take the same data, but use a masked value, which basically indicates all of the non-data sections, and also do a squeeze. And the squeeze is just another artifact of dealing with rasters. Sometimes we want this 2000 by 4000 array of points, but sometimes it's sort of buried inside of a one-dimensional structure that says, there is one instance of a 2000 by 4000 array unit in here. And just the fact that this thing has 3 dimensions can give a little heartburn to some programs that are looking for straight arrays. So by doing this squeeze function and then looking at the shape, we've dropped sort of that initial index. So now I've got a simple 2-dimensional array. If you throw that into a plotting tool, they've used matplotlib, what they had running here. Now we've got something that looks, more dimensional. You can see that it's in the rectangle, there's all this sort of not data on the side that we've now ignored. If you want to poke around, look at your data, it's easy enough to just do plot histograms and see that the values now are also much more reasonable. If you remember up above when we did the histogram, we had all of these non-data data points that were skewing all of our numbers. So now that the histogram looks better, we can now start combining data. And in this case, they're just going to do a really simple combination. They're going to bring in that same data set, but in this case, they're going to bring in a boundary layer that just basically was a marker for the size of the whole grid that was being run, and using these dual plots, we end up with overlaid displays. And for this article, that's all this one does. just get you to the point where you've got these two layers displayed, aligned with each other so that they overlay. Now you could, whatever other data you want to pull in, you can end up doing that as well. In this series, I'm going to pop back up to the top real quick. See, in this series, there were many other sessions that we weren't going to get into detail here, but if I mentioned GeoTIFF, I mentioned what's the other one? GeoJSON, which isn't mentioned here, but it's another way of writing out your data. If you're doing this kind of stuff, these are nice, handy little Python exercises. Real quick, I'm going to pop into my. Hopefully, you see my Cairo testbed desktop now.
Looks good.
Yep. So the exact same code. So just to say that, in fact, it's all pertinent. The only thing I did in here was change the code that they had. Is I already downloaded, rather than go and grab all of the data that they're talking about doing with this this get data command, I had prefetched it. So I basically just have a directory out there, and it's underneath our net file shared space. So in here, we're going to go and dump that data out. So it's the same thing that was described in the article, and just as they described, we're going to go ahead and tells you your no data value. So this was the command that, how do we get that value? How do we find it? This was the no data attribute. And no surprise, just what they just as it was shown in the document, the fact that it was skewed, the fact that it had these, all of these negative values, all of these are run right here in the notebook. I can share this notebook. It's in the same area as the training data is. It's lurking out there underneath net files Cairo data training dash rioxarray. If you want to grab the notebook and tinker around and run other commands, it's available. And that's all I had. So we're a whole 16 minutes in. Do folks have questions about? I know that a lot of folks here have done a lot with the Rasterworks. We've done in previous grants. We read a bunch of land use data sets that we used for how the landscape in our RAC and BRE grant worked. And I know Kristen did work with those. Those are text data sets. They have a separate project file off to the side that tells you what the projection is. Not project, but yeah, I guess it's projection, PRJ file. And in these other seminars in the series, pop back over to that again. Talked about doing things like there's the master data. Yeah, this, the coordinate reference systems. The fact that there are coordinate reference systems, that they are they vary as you go across the globe. And it's easy enough to convert between them in Python using, the commands that are available in these Raster.io and in the GeoPandas work. So apparently I had a really short thing.
That's good. So I will say that, that squeeze command I didn't know about, and that's great because all of our, so I don't know if you guys remember, but we did a bunch of precipitation data projections, precipitation temperature projections out to 2100 back in our last two EPSCoR grants. And all of those files have that like leading dimension, like the projection dimension. So that squeeze command can like squeeze that right out, which is kind of nice instead of having to like figure out a way to get rid of that extra dimension. So that extra dimension is something you see a lot in like climate projection data, satellite data, because it represents like one either projection of the data or one band of the satellite, one spectral band. And so that squeeze command is a really easy way to get that extra dimension out of there after you download it.
Do raster files always have to have one sort of layer, or do you sometimes find raster files that have like sort of different layers or different data like associated with those pixels? So like might have a terrain one, have like a precip layer, or as they typically separate it to different files?
I've seen them. I have seen rasters with multiple values embedded in them, but it's done by encoding the value or the string at each cell. I haven't seen where there's basically multiple arrays in one raster. In fact, one of the things I'm struggling with a little bit in my studies here, the work, is we generate a netCDF file for our lake model simulation output, and it has lots and lots and lots of variables, like 38 variables that we're tracking for this surface sheet. So there's this two-dimensional grid with 38 variables, and a lot of these routines that we're talking about need to basically chew on one of those at a time. So one of those equivalent rasters. So a two-dimensional array of temperature is, you work with that and plot it. And then you pull out another two-dimensional array of the cyanobacteria index and plot that. I haven't found anything that lets me just feed the whole data set. When you do this rioxarray open of a file, you get a structure they call a data set, and inside the data set are a bunch of data arrays, and each data array is basically one of these two-dimensional grids. So moving between them, there's some complexities there, and this is why I've been on the hunt for libraries like this to help work with those things. In our for instance, when we go to GeoPandas to do things, there are geometry elements that we need for GeoPandas to operate, and you need a column in your data with this marked as your geometry, and pulling that out or assembling that geometry from like a lat and a long and creating this geometry column is another piece of Python that you have to piece together. Build this sort of interim data set that you then can run through the plotting tools, make them happy. Right now, the thing I do best right now is make libraries very angry with me by asking them to process data structures that they are not ready to do so. So I'll take a slice and hand it off to a plotting tool and have it be unhappy with me, or to a conversion tool.
Hey Scott, can you go to the X-array data array, like the printout from the original for the original
data display, just the print of what the data structure is after it's read?
Yeah. The one that has the coordinates in it and the attributes. So you'll notice that the underlying data structure for this is an X-array data array, and that can only have one it doesn't have
One active
variable.
data.
Yeah, it doesn't have a variable component. So you can only really put one raster or one layer in a data array. Now you can kind of get around it with that band, right? So if you had band 1, and then another band 2, and then a band 3, you could kind of layer them on top, and you could think about it that maybe your data array was 2 dimensions and your band was time, and maybe you had a raster.
You want me to pop up? You want me to pop up the equivalent listing of our netCDF surface sheets for EM3D?
No, I think that's okay.
That's too deep.
Keep it here. Yeah, and so you could use that third dimension, Noah, to to have it represent different variables or different things over time, but it's kind of a hack.
You'd have to
It's
slice
more
it.
for
You still have
like,
to slice it each time you want to reference it. You'd have to
Right.
basically dereference that band or reference a particular slice of that band.
right. So, but there's no concept of like, you know, the precipitation variable versus the temperature variable within a data array or a raster. Now, having said that, you know that like most of the data formats, like in the files, they often have a slew of variables in there, right? Like grep will often have like a ton of variables. Yeah.
Array data set, which are composed
Yeah.
of many data arrays.
Exactly. NetCDF will often have a slew of variables. So to get from like one of those standard file formats like NetCDF or grep, you'd have to grab a single variable and pull that into raster IO. And that's kind of the way it's conceptually meant to work. That raster IO is like it's one variable or set of very related variables like bands or over time, or maybe a different projection of that variable, but there's no concept of like variables in a raster.
Gotcha.
Yeah. So exactly. Notice when this got read with this open raster, I mean, it came back immediately with this, you know, an unambiguous data array. Just real quick, if I pop into here and, you know, our surface sheets, this is, well, this is a very similar, this was an open data set call.
Right, that's data set.
Right, but it's a data set, not an array. But everything inside of here ends up being an array. So
Right,
each one of these is a data array, and each one of these is basically a raster.
Yeah.
In our case, it's slightly more complicated in that the dimensions X and Y aren't, for us, it's not a regular grid. It's a mesh. So our cell sizes vary from east to west and north to south in our mapping. So we need to pull out in our variables up here. No, not up here. Here. We have lat and longs that we can use, or we have grid X and grid Y, which we can use to give us a better shape. But, you know, once we're digging into these, plotting them one slice at a time. This happened to have been one time slice, a data set of one variable for one time slice, and dump the array. So that's how I'm fishing for, you know, one variable's worth of raster data. Now we're trying to merge those together, which is trying to get to some other formats like a GeoPandas format. And I found this rioxarray as an extension of the libraries, hoping it was going to lead me more quickly from our lake file netcdf to the sort of combining of these images, but there hasn't been a simple path. There's still going to be a lot of data slicing to pull out one raster's worth of data at a time and put that into the rendering tools and combining them. The next step, though, is to get these coordinate reference systems defined so that we can combine things. Like if I go out and get a tile image, a satellite image of the area of study, and I want to overlay that with some coloration for, I don't know, cyanobacteria, or coloration for surface temperature, I need to have them in the same coordinate reference system so that the two grids align when I mix the plots. And that's what I'm doing. And these are the libraries that I'm walking through. And I kind of liked this this tutorial, or this sequence that this Earth Science, Earth Lab analytics group, they've got a whole bunch of lessons out there. So if nothing else from today, I'd recommend folks go look in this Earth Lab section and see if there's topics or little snips of examples. I found it by looking for very specific questions, saying, I want to do this. I want to go from this to that with Raster IO. What do I, who's done it and how is it working? And I found these examples. And then this was a very nice step-by-step tutorial that made sense to me. That's what I got. Anybody else?
Any other questions, comments,
Rasters?
personal reflection on using rasters?
Yeah, historical pain and suffering. Yeah,
I'm used to raster analysis in GIS or in R, and I think Python's come a long way in the last couple of years.
Yeah.
It sounds like, yeah, that's great.
Yeah,
It's great to see.
that 10 years ago, 11 years ago when I came on board, we were doing most of this with ArcGIS or QGIS, and it was much less programmatic and much more point
Right.
and click.
Yeah. And you'd have to come out of your workflow to those other platforms rather than just have everything seamlessly in Python. Which is cool.
Yeah.
Right. So there was a lot of data prep work that was done in an interactive tool to kind of get the slice you wanted, and then you carried that slice down into your analysis tools.
Exactly.
Yeah. So we're trying to shorten that loop.
Yeah.
Or like, I don't know if you remember this, but what we did is we would load up grass and use grass's like hacked up like scripting language that was like nothing else you'd ever seen before. And it was like a bunch of like grass commands. And you have to learn a whole nother programming language to figure out grass
it was,
commands.
Kind of a batch
go
version
back.
of GIS.
Yeah. Yeah.
Yep.
Yeah.
I will not miss those days.
And I don't know whether R has any equivalent raster mangling functions out there or not. We've been
for sure
kind of buried in Python lately.
Yeah, and they do have very similar functions and some nice geospatial tools like interpolation of data across a raster and that kind of thing. So I'll be curious to explore Python a little bit more to see if those are making their way over.
Looking at plotting, and there's various smoothings that can be done, and we're going to be doing some kriging work as well, because our grid points, our cells, that we're doing on the lake are they're homogeneous for the area of that cell. That is what that cell has, and they're of varying sizes. So there's definitely some pixelization or some blockiness if you just dump them raw onto an image. I mean, that is what the model has. If you wanted to have it look smoother, you would have to do various smoothing functions to sort of interpolate between pixels so that they kind of ramp in and ramp out of boundaries.
Exactly.
Yeah.
I'm curious that for our data analytics class, I had an R tutorial for kriging, and maybe there's, by the next time I teach that class, maybe we can do a Python version of that. So
yeah.
Cool.
Another thing I want to see if Python can do with these tools automatically now, I know they're using R for it mostly, is so with next gen, when they figure out the precipitation over a reaches flow area, they have an R code, a piece of R code that takes the precipitation grid, puts a shapefile on top of it, and then automatically figures out the percentage of all the border grid cells that are within that shapefile, and use that in the calculation for precipitation, which is super slick and easy.
Yeah.
But I've only done that manually before, which is a mess. But if there was, but I think we're close. I mean, we're just exploring the last couple of weeks in Python. I think we're close to finding something in Python where you just have your precipitation raster. You say, I want the shapefile, everything in the shapefile, and it automatically does all the calculations and all those edge cells for you, which would be fabulous.
Super cool.
Yeah.
That's great.
I know right now most of the next gen folks are doing that like with some R code.
Mm-hmm. Mm-hmm.
Brings up the question of what else folks would like to see if they have found any areas of interest. Either you have something you want to present, or you have a suggestion for somebody else to go find out how something works and present it. Either of those options to continue on with these seminars.
We also have Dask
So-
on the agenda.
Dask, yes. I did bump into that along the way. We had conversations last week about what to pick, and I was deep in this one at the time, so I said, well, I'll do this one because I'm already up to my elbows. Just trying to get this working.
Has anyone explored EarthPy, which is like this package I think that this Earth Science Lab has put out?
Yeah.
No, I
have
saw it
not,
referenced
but I
there.
did see that it was referenced in some of their tutorials that they use it.
Yeah, I mean, I haven't explored it either, but just like clicking through it, looks like it might be some useful stuff like stacking multiple raster bands like into a single NP array. I don't know. It might be worth digging into in like a future seminar. Just like to see what kind of tools they have there. It's put out by the same Earth Data Science organization.
Yeah. I haven't looked up the story behind this Earth Lab as to what their mission is.
EarthPy says their mission to make it easier to plot and manipulate spatial data in Python.
Yeah.
Beautiful mission. Stack and crop
That sounds
raster
different than
bands from
Earth
data-
Lab. This Earth
Sounds
Lab,
what?
this Earth Lab versus EarthPy. Earth
Oh,
Lab,
yeah.
University of Colorado. Oh, it's University of Colorado Boulder. Tutorials, course lessons, and blog posts related to Earth data science. Teach about R and Python. Techniques relevant to Earth data analytics, including geospatial, social, biological, and Earth systems data. Focus on suite of topics: analysis, reproducible science, spatiotemporal data, remote sensing. Yeah, definitely our kind of people.
Well, if there's no more questions on the raster stuff, I'm gonna stop the record. Any other stuff on rasters before I stop record? Speak now or hold your peace. All right. Oh,
Can I
Marcel,
be
you
done with
got something?
rasters?
No, okay.